All right, all right, all right. We got some questions on mastering physics, and these have come up a lot. So let's do this right. So the first one is 7, 9, and 13, and they deal with a couple of big ideas. So 7's tough because it's dealing with vertical. 9 and 13 are dealing with friction, but they're giving you kind of distance and time, and so it confuses a little bit. 7 is the same thing. They give you a speed, and they give you a height, and they give you a weight force, all right? And so find the average force. So let's start conceptually. So here we go. We have our firefighters. They have a weight force of 788. Guys, remember, you all have different numbers. So right off the bat, 788 is the weight. Well, since weight equals mg, that means 788 equals mass times 9.81 meters per second squared. So if I do 788 divided by 9.8, 80.4 is the mass. So I might use that later. So 80.4 kilograms. Okay. So later I'm going to probably need the mass. So I just got that. I'm like, okay, now I'm done thinking about it. Next up, the firefighter is going down. Well, is it okay to say that there's going to be friction because they give us all this information? They say, what's the force exerted on the firefighter by the pole? And we're going to call that friction. Force of friction. Okay. So that's my idea and kind of starting with. So I'm going to have some friction force here. Watch this. This is the answer because I pulled it off of the answer thing, but 600. It's a number smaller than 788. If it was 788, you do a constant speed the whole way down. But instead, it's going to be less than. We need to figure out how much less than it is. Well, to figure out how different it is than the weight, we need to do F net. So we got to do F net equals ma. So the mass is 80.4. Did they tell us what the acceleration was? Pause? No. And that's the problem here. If they don't give us acceleration, we have to find it. Okay, so since they gave me distances and speeds, I'm going to go this route. I'm going to go old school, guys. We're going to go retro. And so we've got initial velocity. Starts at rest is 0. Final velocity, 4.1 meters per second. Acceleration, we really want that because as soon as we find that, we can plug it in right here, right? How far? 3.5 meters. Time? Don't know. I'm not worried about it right now. So I'm going to use the equation that does not deal with time. Vf squared equals V initial squared plus 2a delta x. So V final squared, this is 4.1. Remember, squared, don't forget the squared, equals 0 squared plus 2a delta x. I'm just going to type in 4.1 just so we have the same number. 16.8 equals 7 times a. So acceleration is 16.8 divided by 7, 2.4 meters per second squared. Just working on our units, right? So look what you did. So you used motion to understand what's my acceleration. Okay, so now I have an acceleration of 2.4. Now I can get an F net. 80.4 times 2.4, 193. The units for force are newtons, so F net is 193. The F net, remember, if it was sideways and if it was only one force, that's my force, 193. But since it's vertical, I've got a downwards force and an upwards force. The F net tells me how different they are. So this force of friction, the force on the pole and the person is 788 minus 193. And so 788 minus 193, 595. 595 newtons. The answer key rounds it because if you look, 3.5 meters and 4.1 meters only has 2 significant digits to it. So what is 2 significant digits on this one? 600. Okay, so it'd be because, does that make sense? Like, because you can't say 595 because that's 3 digits. So but we don't know about that 5 being significant, so we can't use it. So there's that one. All right. Hit next. Here we go. So we have a sprinter wishes to accelerate. I think that's just the best way to say it. From rest to a speed in a distance. Are you noticing that they're giving us this information right here? Okay, so initial, final is 13, displacement is 30. And remember, since we're dealing with forces, what's the variable I want? I want acceleration. I'm not concerned about time. And once I get that, I'm going to do F net equals ma. Now, this is where we got to go. Okay, what do we do here? So we've got what coefficient of friction is required. Okay, hold on. So here is the sprinter, normal force, weight force. I promise you that's supposed to be straight up and down. Right? They want to start going this way, so the friction force will be in the direction that they want to go because they're pushing off the ground and the ground pushes them forward. Well, let's find out what our F net is. Let's do that first. And then we're going to see how does that help us here. Okay. So we got VF squared equals V initial squared plus 2A delta X. 13 squared equals 0 squared plus 2A times 30. So I get 169 equals 60A. So I get an A of 169 divided by 60 is 2.8. All right. So I have my acceleration. So watch this. F net equals M A. And let's let it 81. Oop. Okay, 282. Please notice it's nowhere close to the right answer. Okay, so I think that's tough in this class. Sometimes you'll put it in a calculator, you get a number, and you'll be like, am I done yet? Nope. So sometimes the thing you calculate is just a piece of the puzzle. So now we got to take that piece and go, okay, I got an F net, the F net for my situation. Now let's look at my diagram here. If I look here, I got a normal force and I have a weight force. They cancel each other out. Okay. Here's my friction. Do I have anything going that way? No. So if my F net's 282, how big is my friction? 282. Okay. So let's think about what my equation is for friction. Force of friction is mu times normal. What is my friction? 282. Mu is my coefficient of friction. Don't know what it is. Normal force. Mass times gravity is the weight force. Since we're doing Mastering Physics, I want to use 9.8, so I'm going to get this as accurate as possible. 794. So the weight force is 794 going down. So what's the normal force going up? 794. So if I solve for mu, I get 282 divided by 794. I get 0.355. Now I'm highly concerned right now in that I did not get the exact number. 794 is good. And then what's 13 times 13? That's right. Divided by 60. That's right. Times 81. 282.15 divided by I'll plug something in wrong because how did I do that? So I got 282 divided by 794. I guess this is, I just recalculated, this is 795. So 282 divided by 795. I'm baffled right now. Oh, Schmier is bad with numbers. Ready? This is 228. Schmier found out 228. I just switched those numbers. This is 228. So 228 divided by 795. That's 2.9. Woo, 0.29, I mean. Holy McSmokies. I was questioning a lot right there. Okay. That is why, if you look at this, mastering physics is pretty unforgiving. Look, I made one mistake. I switched the 8 and the 2. I got the whole problem wrong. Guys, that's why I curve it. It's also why it's really good to show your work, because I was able to go back and see what I did wrong. So that was number 9. This is taking a little bit longer than I wanted, so let's get into 13. Here we go. All right, number 13. Car accelerates at 15 meters per second without spinning the tires. Determine the coefficient of static friction. What? Hold on. There's a tire. Don't judge my pictures. I heard you silently judging me. There's weight force. There's normal force. Okay? Car wants to go to the right. That means the friction is to the right. Okay. Whoo, they give us acceleration. So I know I'm going to do F net equals ma. Okay? I want to give you a strategy. From my picture, what is my F net? It is the friction force. Okay? That thing right there is my F net. Watch this. If the friction was 12, what would my F net be? 12. So that means the friction force is the F net in this problem. Like, they're equal to each other in this problem because the normal and weight cancel each other out, and we're just left with friction. So the equation for friction is mu times normal. So look at what we're doing here. We are writing an equation that's just the same every line. So look, friction equals mu times normal. All I'm doing is substituting in. Now, what is normal force equal to in this problem? Normal force equals the weight force in this problem. And now, if you look, we had a serious glaring issue in the problem. Did they anywhere in the problem tell us the mass? No. But look at both sides here. See how there's mass on both sides? So if I divide one side by m, what do? Cancel out. So I'm left with UG equals A. So U times 9.8 equals A. So I get 15 divided by 9.8. I get 1.53. These are very sticky tires, by the way. There you go. This is one of the reasons why before races they'll spin their tires to make them warm so they're a little bit stickier. It's also a reason why in the wintertime your tires don't do as well because they actually become more brittle and so they don't stop as well. So snow tires, what are snow tires? They are rubber that stays soft in really cold temperatures. How do they do in summer? They wear out really fast because they're super soft. So it's like a catch-22. So there you go. Hey, we talked about some big stuff. Okay. I know this might have helped, but I also know you might be going, I'm still missing stuff. Yeah, let me know. But hopefully this helps a little bit. Thanks for tuning in. Wash your hands. Be nice to each other. See you guys.